Okay. Okay. So first off, we are going to learn what is a scalar, and then we're going to learn what is a vector. So basically, when you look at a scalar, you say that it is a quantity with magnitude only. A vector is a quantity with a magnitude and a direction. So probably you guys know this already. So we're gonna list some of these. Okay, so some known scalars are distance, speed, time, mass, temperature, energy, pressure, work done, power, okay, and what else? Current is a scalar, voltage is a scalar, also resistance is a scalar. Okay, so usually they will ask you directly which are scalar, which are vectors, so you should remember this. On the other hand, you also have like some vectors like displacement is a vector, velocity, acceleration, force, moment, momentum, and impulse is also a scalar. If you have any questions, please let me know, okay? All right. Now, it is very important to learn about the representation of vectors. Okay, so when you look at a vector, it is usually drawn through why won't you open the shapes? Okay, this software sucks. Gotta restart it. Okay, Alright, so as I was saying, when you look at any interesting. Okay, so when you look at a vector like this, so you should remember that the arrow basically tells you the direction, and the length tells you its magnitude. So if you have you're comparing two vectors, like let's suppose they say two Newton to east and 5 newtons to north, right? So what you're going to do is, you should always remember this, okay, that this is north, this is south, this is east, and this is west, right? So 5 newtons will be a longer vector and it is north, and 2 newton is shorter vector which is towards east. So we can draw this. Is it clear?
Yes, sir.
Good. Now, to solve vectors, we have three different methods. So the first method is called parallelogram. The second method is called vector triangle, and the third method is resolution. Now, interestingly, we need to learn all these because the examiner might ask you to do one of these, or he can give you a choice between them. So it's his prerogative, right? So we are going to learn all of them so that we are well prepared. Now, parallelogram method is just graphical, but vector triangle is not only graphical, but you can also use math to solve it, so we can call it analytical as well. However, resolution is only analytical, and you have to use your mathematics to solve this. Interesting. Now, so first we are going to learn about general vectors, and then we are going to learn about how to use their variations, right? So let's talk about case 1 only. Case 1 is when two vectors, two or more vectors are, number one, they should be parallel and in same direction. So what you do then, let's suppose there is a body. One vector is like 10 newtons, the other vector is like 5 newtons. Now, to find the resultant, it's super easy that you say, okay, the resultant is 5 plus 10, which is 15 newtons towards the right. Okay, so you have to give the direction as well. Another way is that you say, okay, I'm going to take all the vectors which are towards the right as positive and all the vectors towards the left as negative. So you could just add, you could just put positive signs because they're towards the right. So you can also write, if you've defined it, 5 plus 10 equals to 15 newtons positive. Positive means that the resultant is towards the right because you put positive sign towards the right. Now you need to understand that positive does not mean that something is bigger than the negative number. In fact, it just means what is its direction. So you have to look at that way. Now, case 2 will make it more clearer, like two or more vectors are parallel and in opposite direction. So suppose you have a body like this. You have 10 newtons here and 5 now on the other side like this, parallel but opposite. So one way of doing this is like you do that resultant is equal to 10 minus 5, which means 5 Newton, because 10 was bigger, so we can write that it is 5 newtons towards right. However, if we do the same thing, right, we say, okay, right side is positive, left side is negative, so we have to put a positive sign here and negative sign here, which means then when I'm gonna solve this, so it's going to be positive 10 minus 5 will give me positive 5. Now because the positive is there, it means that it is, the resultant is towards the right. Do you guys understand this?
Yes, sir. Yes, sir.
Now it is not necessary, right? It is not necessary. Well, let's suppose Aisha was like, why do I listen to sir? I could take this as negative and this side as positive. So she can do it. And then when you're finding resultant with this respect, right? So you should understand that now 10 will be negative and 5 will be positive, and when you add them you'll get minus 5. Because you took minus sign on the right, which means it doesn't change the answer, because negative shows the direction that 5 Newton is towards the right. Do you guys understand now? So it does not matter whether you take right as negative or positive. What matters is that if you have taken right as negative, then left has to be positive. Both cannot be negative. Is it clear?
Yes, sir.
So we can actually write here that signs only show the direction. All right, they have, I mean, you cannot say negative 10 is a smaller number than positive 5, because in vectors that's not the rule. In scalars we say that, but not in vectors. Okay, now let's go forward. Now the real problem comes when the two vectors are not parallel. And when this comes, then you have to actually use one of these methods to solve it. So suppose we have the same body. This time you have 10 newtons here, but 5 newtons is actually at 40 degrees, like that. Now because they do not have opposite or same direction, we cannot just simply add them or subtract them. We have to use a different method to do it, right? So let's look at it. First of all, we are going to learn the graphical methods, and I'm sure most of you have done it in O levels, because in O levels only graphical was there. So in graphical method, the first thing you always do is that you take a scale. Scale means that you could say, okay, 1 centimeter is equal to 2 newtons. So if I've taken a scale, it means that I have to then draw this with a ruler. So which means that 10 Newton would be drawn for 5 centimeter, because according to my scale, if 1 centimeter is 2 newtons, then 5 centimeter would be 10 newtons. Is it clear?
Yes.
Then what I'm gonna do is, I'm gonna draw. This method I'm teaching you parallelogram actually. So you can write that's parallelogram. Draw the next vector. Okay, I can't write it here. Vector from starting point. So what you do is you put your protractor like this, you measure 40 degrees, and then you extend the line like this, and this line will be actually 2.5 centimeter, because that would represent 5 newtons according to your scale. Is it clear?
Yes, sir.
Now then, whatever method you've learned in O levels, you use the same method. You make parallel lines. Now, to make parallel lines, well, you can use a compass, but I don't really like compass because it's too complicated sometimes to adjust it. So what I do is I put the protractor again and I measure 40 degrees again, because I want to make a parallel line to this. So when I make a 40 degrees, the same angle corresponding, when I extend this line, this would actually give me a perfect parallel line of 2.5 centimeter, like that. And if you now then connect this line like this, so you get the same parallelogram, and then you can remove, of course, the protractor like that. Easy. So once you've done that, then what you do is that this point was your start and this point was your end. So basically from start to end, you just draw a vector like this, and this will be your resultant. So the next step is that you draw a line from start to end. Start to end means that basically in the start of your diagram where you started, you put your pen first, and at the end of the diagram. What you do then next is that you measure the length of resultant using a ruler. So when you measure the ruler, let's suppose that the resultant R came out to be like 14 centimeter. So what you do then, okay, not 14, that's too much actually, sorry. Let's say it came out to be like 7 centimeter. So then you would say, okay, if 1 centimeter on my scale was 2 newtons, then 7 centimeter would be, you cross multiply, that would be 14 newtons. So you get 14 newton as the resultant. Is it clear?
Yes, sir.
Now for the direction of the vector, you again put your protractor like this. You measure this angle actually. When you did this angle, let's suppose this angle comes out to be like say 18 degrees. So you say, okay, the direction is 18 degrees from the horizontal. That would give you exact location of the vector and its value. Any questions now? Please let me know. Okay. Now that's I think pretty simple, right? Because you've already done it. Okay, now the next method that we have to use graphically is the vector triangle, like I told you. And some of you might have done it, some of you might have skipped it, because in O level some teacher prefer this over parallelogram. So we're going to take the same example, right? let's copy it to save some time. Okay, pretty good. So for this, you do the same thing. Always take a scale. So when you take a scale, so let's take the same scale, 1 centimeter equals to 2 newtons. Of course, the scale could be different for you because you might be, thinking that I need to look at maybe the page size is smaller. You could use a different scale altogether to fit your page. Scale is not important as long as you use it wisely and the page size is, kept in mind. So what you do then is you draw any first vector. So let's suppose you decide that okay, I'm going to draw the 10 Newton one. So you draw 10 newtons, which will be equivalent to 5 centimeter actually. Now what you do next is important, and then you basically use head to tail method. Now what is head to tail? Basically head to tail means head of the first vector connected to tail of the second vector. This is what it means. So what you do is, because this vector was 40 degrees from the horizontal, so I'm going to put my protractor like this. I'm going to measure 40 degrees. Okay, this is 40 degrees. And then I will connect it from the head of the first vector and draw 2.5 centimeter, which is 5 newtons. So if you look at here, you see the head of first is connected to tail of second. Everybody understand this?
Yes, sir.
Now once you have done it, because I like this so much, because you don't have to waste so much time. Once you've done it, you just need to draw a vector from start to the end, and that's gonna be your resultant, right? So fourth part is that you basically draw a line from start to end. Then you basically measure the length, and that's it. So when you measure the length, it would basically, I'm just assuming the values, okay? So let's suppose the length of the resultant comes out to be 7 centimeter again. You like, okay, 1 centimeter is 2 newtons, then 7 centimeter will be 14 newtons. And similarly, what you do, you put your protractor right here, you measure this angle, and then you say, okay, this angle is 18 degree from horizontal. So that would give you the resultant and its value. Is it clear?
Yes, sir.
The funny thing is that if you look at the two diagrams, right? Let me show you this. If I erase these two, you see it makes the same thing. So actually, vector triangle is so good because it helps you basically get the resultant in less amount of time and less drawing. That's why. Otherwise, if he has asked you to make a parallelogram, then you're in bad luck. But otherwise, I would always prefer vector triangle over parallelogram. Okay. Only thing is, you need to remember that I have to do head to tail rule. Okay, you can draw this, please. And then we are going to move towards the analytical part. Okay. So, bachcho, should we go forward then?
Yes, sir.
Cool. Okay. Now, going towards the next thing, we are basically moving towards the analytical method of vector triangle. Now, before we do that, some of you might have taken maths, some of you might not have taken maths, right? So I would like to give you two formulas that you need to remember, okay? All right, so let's talk about them first. The first formula that you need to remember is called the cosine rule in mathematics, which is basically c square equals to a square plus b square minus 2 times ab cosine c. The other rule you need to remember is the sine rule, which is sine of a over a is equal to sine of b over b equals to sine of c over c. Is it clear, everybody?
Yes, sir.
Yes, sir.
So what you guys need to remember is whenever a triangle is there, right? Whenever a triangle is there, does not matter which type of triangle. A means side A, side B, side C, and the angles are like opposite of A it is A, opposite of B it is B, opposite of C it is C, like that. So for those who do not have maths or never had maths, so they should remember this. Now why this is so important? Because about 70% of AS questions in paper 1 will ask you to do this method, or you will be forced to do this method, right? So you must write this formula. Now, so going on with my first example, so you will learn how to basically use this. Suppose we have a vector which is like this, which is say 500 meters per second. Oh my god, that's too much speed. And then one vector is like this, which is 200 meters per second, and they have given an angle of 30 degrees in the center. And they say, okay, find the resultant, right? Now we'll be like, what do we do, right? So do not worry, my friends, we will do this. So the first thing is you always use head to tail rule. Now I have not said that you have to take a scale or whatever, because this is not graphical. You can just draw it like you generally draw it, right? You don't have to be very specific. So suppose Khatija says that, okay, this time I'm gonna take 200 first. So draw 200 at, it's 30 degrees, and this is 200. And now what you do is draw 500 connected from the tail of the first one. So this is 500. Because it was horizontal, so we made horizontal, right? So your head to tail is complete right on this part, you see? Now, the same thing, you just use your resultant like this, and that would be your resultant here. Now what you do? If 30 degrees was here, then I could say that the alternating angle or alternate angle is also 30 degrees here. Do you guys agree?
Yes.
Now, on a straight line, the angle is 180 degrees, which means that this angle would be 180 degree minus 30 degree. So that is going to be 150 degrees. So we have to find the angle that is exactly opposite of R. Once you have that, what you do then, you say, okay, R square, cosine rule, is equal to 200 square plus 500 square. Okay, these are two sides, minus 2 times 200 and 500 and then multiplied by cos of the angle opposite to r, which is 150 degrees. Do you guys understand now?
Yes, sir.
Now here I'm gonna give you one tip, and the tip is always check, because in math you will be using radian mode, so always check your calculator is in degree mode. That's very important, otherwise you will get wrong answer. Okay, so let's pull up the calculator. Put it right here. So what we're doing, 200 square plus 500 square minus 2 times 200 times 500 times cosine of 150. So this, and to find r we also need to take the root of this answer. So we take root, we get 681 meters per second as our resultant. As simple as this. This will take you like minimum 1 minute. Is it clear?
Yes, sir.
Now we need to find the direction of this, because we also need to know where it is located, right? So to find the direction, if I get this angle, right, I can then find we can subtract from 30 and then we can find this angle, right, to know. So for that we are going to use sine rule. So we're going to write sine of r over r equals to sine of theta, because we need to find theta, and the opposite side is 500, so we're going to write 500. Instead of r we can write, okay, we can write again. So sine of r is 150, r we just found out to be 681. This is sine theta, this is 500. So now let's try to figure this out. So sine of 150 divided by 681, and then we got to multiply 500 with this. So we got this, and we take inverse of sine answer, so we're gonna get 21. So theta comes out to be 21.5 degrees. So we can subtract this theta with 30. So 30 minus 21.5, we're gonna get this angle that we need. Okay, so 30 minus 21.5, 30 minus 21.5, this gives me like 8.5 degrees. So now I can write the answer. I could say, most of the cases he would not ask you this, sometimes he does. So resultant is 681 meters per second, and the direction of this resultant is 8.5 degree from the horizontal, because we found this angle to be 8.5 degrees. Is it clear, everybody?
Yes.
Yes, sir.
Perfect. Now what I'm going to do is, I just want to give you one question. Okay, if we all solve that question, it means that my job is done today. So let's do that. Okay, so this question is from the exam paper. Okay, so I'm just drawing it because it saves time. So they've shown one vector like this, which is 7.5 newtons. Then they have shown one vector like this. Okay, this is 2.5 newtons, and this angle is 30 degrees. So they've shown this. Okay, so they say in part 1, draw the resultant force. In the second part, they say that show that the magnitude of this resultant is 6.6 newtons. Can you guys do this? Okay. Now what I'm going to do is I'm creating a classwork on the Google Classroom. Okay. So you do it on your paper. I want everybody to solve this and upload right now because I'm going to check it today and then you will be allowed to leave. So classwork has been uploaded. You just go, when you draw, you take a picture and you put the picture you have to take a picture and then you have to submit it. Okay, you have 5 minutes, please. Just follow the steps, okay? I would be very happy if you do it analytically, okay? Otherwise the other methods are also fine, but because the examiner did not, ask you to do one or another, so you can use any other method, but analytical method would be, because this is the first time you're learning that, so that's fine. Okay. Okay, you guys done? Okay, 2 minutes are still left. Lol, it's okay. Interesting. Okay, hurry up, 40 seconds. Quickly, everybody. Let me check who's in today. Okay, a lot of people are not. Why? Why? Okay. All right, you should submit now. Hurry up. So, till you guys are submitting, but you should by now you should be done. Let me check who hasn't submitted yet. Hurry up. Okay. Come on, you guys. You're boring me.
Sorry, sir, I had to restart my drawing because I made an issue.
Okay. Alright, I'll help you this time. You guys upload, okay? Still, you need to upload your work and check. So, if you draw like 7.5 newtons first, like this, so you should also know that you have to draw the other vector from the head of the first vector, like this, right? Which is 2.5 newtons. And you should know that this is 30 degrees actually. Now, this the resultant will always be like from the start to end, so your resultant should look like this actually. Okay, now if this is 30 degrees, then this angle is also 30 degrees. Okay, which means that this hole is 90, so this angle will be 90 minus 30, 60 degrees, like that. Now it is super easy because you do r square equals to 2.5 square plus 7.5 square minus 2 times 2.5 and 7.5, and then cosine of 60 degrees now. So let's take out the calculator, put it here. So 2.5 square plus 7.5 square minus 2 times 2.5 times 7.5 times cosine of 60, and then you got to take the under root. So here you have the answer, which is 6.61 newtons, and shown like that. All right. Any questions now?
No, sir.
Wow, perfect. So now still I'm waiting for your work.